Okay, we are live. Hello, everyone watching on YouTube. This is Core Protocol Sync on Tuesday. We'll go around and explain what we've been doing as it relates to the core protocol and what our plans for the near future is. Who to start with? Ivan, let's start with you.
Sure, yeah. Give me a sec. I will share a screen. Um, yep, here it is. So last week I was mainly focusing on the adding databases for P syntaxes to file offsets and vice versa. So the point of this is that once we will have it, it will be easier for us to do a partial replica. So basically, PR works as follows. We just added a bunch of abstractions here for the clear distinction from the piece offsets and indices, because we beforehand we didn't have those. So also, yeah, the main focus, of course, was on the plotting side. Yeah, we basically I basically modified some of the encodings and I mean the queries to the plotter itself who goes to the disk, and yeah, right now it will actually write out of order. I mean the indices and the offsets on the disk um, will not be the same. So yeah, that's why we will also need to have the two databases. Yeah, which is done here. Basically, one of those is a database for the mapping from the index hash to disk offsets for the pieces. So this is just a wrapper of the RocksDB, and another one, yeah, the piece offset to index. It is just a file, a binary file. So yeah, it can be um, just indexed by the offset itself. So we don't need um, to write it to write the offsets themselves on disk. So we could save up some space. Um, yeah. Um, Also, another discovered a bug after we merged this PR. Actually, I already found the what's the point of those of that bug? The blocks stopped producing. Yeah, we didn't have tests for those. So the issue was that here the offsets themselves are just numbers, like from one, for example, 0, 1 to 3, etc. Yeah, but here I implied that they're supposed to be um, divisible by the piece size, but they're actually not. So this is the issue. I'll submit the PR with the fix today. Yeah, I also hope to finish the regression tests for that. Yeah, another thing which also I focused after the finishing this PR was fixing tests. Yeah, there was a test for the plot itself. Yeah, the main issue with this test was that we hit some kind of minor bug, which we discovered before, which we didn't discover before. So, for example, here here we just create a new plot. It's supposed to be empty. We just write some of the pieces to the disk. After that, we read it, and when we just drop the plot. After we dropped it, we actually opening it once again. And here the bug for me actually occurred because um, the thing is that we have a plot worker which is actually working in the background, and after the plot is dropped, it needs some time in order to sync up all the data to the disk. Yeah, because because of some cache layering and etc. It takes some time. So um, when I hit this line, I actually the code tried to open the RocksDB, um, um, which is needed for this plot worker in order to serve write requests. Um, yeah, the issue is that it tried to acquire the lock, which is not dropped when it's supposed to be dropped here. So yeah, this is why I have this PR. Yeah. Also, I've been working a bit on the partial replica itself. Yeah, but it's not finished. I was focusing on finding bug. Yeah.
Question, Yvonne, if you
Mhm.
could back up. So the first, so you added the, you said 2 databases. The first was the piece index to offset. So
Mhm.
that allows us, if we need to retrieve a piece over the distributed storage network, to reconstruct it, right?
Yeah, right.
And what was the second database mapping?
Vice versa database. Like the database from the piece offset of which is actually on the disk to the piece index.
Okay. And why do we need that?
Yeah, let me recall. As I remember, we need them for the rewards. Yeah, let me just find it. Oh yeah, in order to retrieve piece by index, because we're supposed to.
Well, it says piece by index, but it's actually piece by offset, it seems like.
Yeah. I mean, we give it offset, and it returns the index itself.
All right, piece index, not by index. Okay.
Oh, sorry. Yeah. I mean, the key is index. Yeah, that's what I meant.
Oh, so the key is not the offset, the key is the index in the second mapping.
In the second mapping, the piece offset is the key. Yeah, here's the
Okay.
here's the functions get and put for this
Okay.
database.
But why do sorry, I still understand why we need the offset in the
Uh,
protocol. Just, I mean, forget about the code, just in terms of the protocol, like what part needs that?
Yeah, it's just that I can't recall it right now. That's why I'm looking for that. Yeah, the point is there is some places where we need to find the. Oh yeah, we actually store the. We have the commitments database, right? And we actually store there on the offset, not the piece index. So that's why we need database for the. Um, mm, we need a database for the retrieving the index from the offset.
I see. So whenever I find a valid tag that satisfies the solution threshold, then I get an offset as
Yeah.
the return value. Then I have to go back to the index database, find the index. But I mean, couldn't I just read the piece from there? Do I need to?
You can read the piece, but you need piece index in order to offer a solution, so everyone knows what piece index that is.
Yeah.
Is the piece index not embedded in the witness?
No.
No.
Without piece
Okay.
index, witness is not valid.
It's just the segment. Okay. I thought that we included that in there so that it was self-validatable. Okay.
No.
So could we not just store the index in the tags database and then read that from the index mapping on each read? Because that's rare, right? To actually get a valid solution, and so the cost of that should be negligible.
So we can. There is a challenge though. So the challenge is the following. We can potentially remove one database. We can map our tags to the piece index. We can hash piece index. We can go into table which maps piece index hash to offset. We can basically get everything. The problem is we do not have piece index stored anywhere except the commitments database. We only have hashes. So as soon as the commitments database is gone, we lose all the information about the pieces that we store. We have hashes, but we don't have the piece index anymore. So it's very important to actually have another just plain binary file which has just like pieces, all of the indices there, so we can always retrieve them.
Wait, so in the scenario you're describing, where we only have one mapping? The mapping would be
This
index to offset?
index hash to offset.
Okay. And that's a problem because
the only place where index is actually stored in the commitments database. If, let's say, all of the commitments databases are out of date because you've restarted your node or your farmer like 10 days later, and the salt already changed, you delete all the old databases, you create new ones, but what are the piece indexes? No gonna know.
But you wouldn't delete the old database. I mean, you could still read the old database to do the mapping to the new commitments database, right? I mean, you could read the old mapping because you're still going to have the old mapping.
Yes, but that also creates some problems. For instance, when you want to actually solve and recommit at the same time, you need to have kind of exclusive access to this database. So like there are some implementation challenges and inefficiencies which arise from this. And it's just easier to have this database just plain binary file. And it's not really big. It's like the number of pieces that you have times 8 bytes, which is not a lot.
So that's about 10 gigabytes at a 1 terabyte plot.
Probably something like 0.1%.
1% or 1%.
1%.
0.1. Yeah. Yeah. Yeah, it just feels a bit like, I mean, it makes it easier from an implementation point of view for sure, but it just feels like it's at like the whole point of the farmer's dilemma, right, is to reduce the overhead to maximize the amount of available storage, and so we're basically just doubling the mapping overhead here.
Yes, we are. The good thing is this is not like the part of the protocol. This is implementation design. So we can potentially change it later, or someone can come up with like alternative implementation that we can adopt. But this is the way that I think makes sense right now.
Okay.
Yeah.
Okay. I think we just need to make sure that we note this like in an issue or like a improvement feature to optimize this, because it's basically technical debt that we're incurring here that we've got to remove at some point in the future. From an incentive compatibility, I mean, not from an implementation point of view, but from an incentive compatibility. It's like protocol, I don't know, network technical debt. It's not the normal sense of technical debt, but it is something which we're going to have to pay for eventually. We're going to have to fix, or someone will.
I'm not sure we will. Like, this is one of those cases which is kind of like annoying, but it's also kind of necessary. So we may end up never actually fixing it.
Okay, I think we should still note it and come back to it and evaluate it. I think it's solvable.
Okay.
Okay, so Vaughn, if you can create an issue
Sure,
to
yeah.
describe this, and then we'll just keep that open and in the backlog, and then we'll come back to this in the future.
Yeah, of course. I will do that after a meeting. Yeah. So yeah, apart from the this bug fix, I don't have anything else to show. Yeah, that's it from my side.
What is your educated guess? How much time do you think it will take to make the partial replica working?
I will try to fit till the end of the week. Yeah, at least to show some of the version, like a more simple version.
Okay, that would be awesome. Any other questions, Ivan? Okay. Ozkan, do you have anything to share this time?
A very small question, not anything to show, but a question. So the reason we cannot update Tauri is because of some dependencies related to Substrate. Some packages conflict. So yeah, there is something like that.
Okay, let me probably help you with that. If you can describe this somewhere, because again, I hear about this for the first time, but I should probably be able to help.
Okay.
Okay. Lucheng, what was happening on your side?
Okay, sure. So share a link and share my screen. Okay, so I have also updates the progress on Notion. So on the last call, we have a list of problems is to be solved for the proof verification. The first one is we don't want the overlay, right? So yeah, this kind of it's already solved. I have submitted a PR to the Substrate. It's on review progress. The idea is we make a wrapper around this back end of the parent state and this overlay. So yeah, the core idea is to make a back end for this state before executing the target extrinsic by merging the actual back end and this overlay, these delta changes.
So you introduced this delta backend as a new feature, right?
Yes.
Okay.
Yes. So this is kind of a true state for executing this target extrinsic. It's suggested by one parity folk. Yeah. So I have verified the whole progress, the proof creation and the verification on the secondary node. Yeah. The test is all good.
Hey, Licheng, let me just
Yeah.
make sure I understand what you just said. So right now, we can have a secondary node or an executor produce an invalid commitment to the state, an invalid block transition, and then another secondary node will detect that, generate a fraud proof, and that fraud proof can then be validated by another secondary node. Is that right?
Basically, yes. Yes. Basically, yes.
Okay, awesome. And does it work in both cases where you have a valid fraud proof and an invalid fraud proof, and they're both tested?
Yeah, no, I haven't write all the cases you just mentioned. I actually just make a happy path for this verification. I create a proof and someone can verify this proof.
Mm-hmm.
If you
So it's like the happy. Sorry, go ahead.
Yes, correct.
Okay.
Happy unhappy path.
Yeah, the happy and happy. That's what I was going to say.
Yeah. Yes.
Okay. Awesome. That's great.
So yeah, the second problem. Yeah, I have some ideas about this. Yeah, it's still suggested by the folk. But I haven't to verify this. It's still a work progress, but I think it's promising. I think we basically still need to add a new API which is basically same with this apply extrinsic API, but at the end of this API we return the final new storage root and the return value. Yeah.
So basically the root that we'll include in our execution trace.
Yes. Nope, it's not. It's used to compare the state after this extrinsic execution. So it's kind of like this. I'm still like verifying the whole process, but I think it's promising. Okay, it's kind of this. Like we add a new API to the executive palette, which is like at the end of this method, we return the final storage root. Unlike this original apply extrinsic, it's just a return this apply extrinsic results. Here we return this like a new storage root at the return value. And then
Okay, I have a question then. Why cannot we call this storage root from the outside manually? Like call apply extrinsic just like you do here, and then
no, because the proof verifier needs to like exactly like execute this extrinsic write. The proof verifier has the pre-state, like the pre-state root, right? And then this like a verifier will execute this extrinsic on its own, and then compare its own like post-state root with this one received from the network or included in the for the proof, right? So
right, I'm just wondering, like, why do we need to add it to Substrate? Like, why cannot we call these methods from the outside? Like, it seems like the API is already there.
Nope, this one is not in Substrate. This one is in our Subspace.
Oh, okay. So what was added to Substrate then?
Nope, not in this problem. No changes are required to submit it to Substrate for
Okay.
fixing
Okay, makes sense.
this one. Yeah. And about this third problem, yeah, this kind of the most easy one, the easiest. So basically, this like the WASM builder already like flexible enough. We can like build a secondary runtime like in the Subspace runtime. We just to modify the build script of the Subspace runtime, and we specify this like directory for the zeros runtime, and we can set a new file and for this. But the most important things for this problem, I would say, is the whole process of the zeros runtime upgrade, which we need a test for this. So yeah, this is still not finished.
Quick thought on that. I don't really like that we are calling into external crate from another crate to build the WASM binary. That seems to be wrong. I was thinking there is basically some kind of FFI API that WASM bundle exposes for someone to call from the outside, like some exposed methods. Maybe, just maybe, we can build both runtimes into the same bundle and have, let's say, like a prefix which is custom to each one, or like just like a module in Rust where like it's namespaced separately. So you can have like one physical bundle which is like universal, but like primary runtime will call like into one set of functions, and the secondary runtime will call into second set of functions, but they are like the same.
Actually, I have like a problem. Are we going to store the zeros runtime in the state of Subspace?
I think so.
In the state or in
the
history?
State, yeah, in the state.
The blob, you mean?
Yes.
The WASM blob?
Like yes.
Why do we need to store
The
that in the
car-
state?
You like you need this like the for the like for the whole
Well, this is where the runtime is usually stored. Like it's stored in this state database, I believe.
Oh, okay. This is just the default for Substrate.
Yeah.
I guess I was thinking, I mean, as long as we just include a hash of the runtime blob in the state, we can just store it in the object store, right? Just treat it as an object in Subspace, and it's always retrievable. If we need to.
Well, but you don't want to retrieve it before you run every block.
Right. Well, I mean, you can retrieve it, but I guess maybe I just don't know.
I think the way it works, you store it in the state and you have like a hash of it, and then you explain to the runtime at which block height you need to switch like from one hash to another. So you can like do it atomically or something like that. That's, I believe, how it works.
Yeah,
Okay,
right
so
now
it's not
it
like
just replaces the entire hyphen code prefix, and every time the runtime picks up from that particular prefix. And if it's an upgrade, it automatically replaces that in the current block. And then the next one automatically picks from the same location, so it just works out of the box.
Okay, so it's not like you're storing the whole blob in the state. It's just a reference to the blob is going in the state.
Nope.
No, we store the entire blob in the state.
Oh boy. Okay.
So that's why I think they usually cache at least 3 runtimes, or at least two at least, I think, between the upgrades, so that they don't pull it up every time they need to use it, because it's going to be a heavy read with all the.
It was the reason for slow tests in one of the observations that Lucien had. Like it was very, very slow.
Okay. I guess I mean, I get that that's okay. I understand now that's how Substrate works today. Is that strictly necessary?
Not I would say, like, I think, as you mentioned, I think the code hash would also works in the sense, like, as long as it has a retrievable farmer node that can give on demand, and if we can follow a simple caching logic like we do currently, I guess.
I just don't see like the benefit of modifying that if it's like already there and it's like a few 100 kilobytes usually, or like at least at most megabytes.
So storing this like WASM blob in the state is the key to the forkless runtime upgrade.
Yeah, but you could still do forkless runtime upgrades if you did it off a hash as well, as long as the blob was stored like in the client, and like Ved was saying, you just like cache the last like 2 or something like that, but you can always retrieve one from the object store if you need it at at some point in the future. But okay, I get it. It's not important right now. I'm just thinking into the future, if we have like some shards with shard specific runtimes, that it might be a lot cleaner to use the object store as like a retrievability layer for this. But I think it's probably way out in the future, so it's not worth discussing right now.
I have a quick question on that. Are we expecting usually the farmers to run the executor nodes, or because like looking on that end, like if the executor node needs to have a connection to the key value stored layer, could be a farmer network, then ideally they are kind of strictly dependent. Every executor would ideally need to run some kind of a farmer network that can give the availability, right? In that sense, we are kind of depending on a different service altogether there.
So the way it's supposed to work is there is like I like to call it consensus part, which is like block production on the farmer side, which is like kind of like a blockchain, but it is a blockchain. There is another side which is execution, which is also kind of like blockchain, but it is like completely derived from the primary chain, from the consensus chain. So even though farmers, they usually only like run like the first part, they only produce blocks, they do not run execution, but they still need to have access to the runtime, because if there is a fraud proof about some execution, they need to be able to spin up the VM, run the transaction, and verify that it actually corresponds to the output that it's supposed to.
Okay, cool. Okay, so that makes it like a mandatory to have both the networks running if I'm running either one of it. And
Yeah,
not
so
just
executors always run the first part as well,
Okay.
but the second part is like optional.
Okay. Yeah, makes sense. Okay, cool.
Yeah, an executor has to run a farmer client. It can't work without it. But the executor extrinsics are actually broadcast on the farmer network. So from the farmer's point of view, there's no executor network. It's just a special extrinsic that it sees on its own network.
Yeah. In that case, I think makes sense, Jason. Yeah, like what you're suggesting as well. Like we have it, so why not use it?
Okay,
So
sorry for
basically-
the distraction there, Li Chang. Did we answer your question? Or did you have an open question there on the secondary runtime on the primary node?
Actually, we can discuss about this once we like really come to that point. It's like still a few steps away. Yeah, the last like issue, I haven't like find any time to work on it, so that's everything on my side.
Okay, and for the go ahead.
Yeah, until like the substrate changes required are like merged to substrate, I basically can't open up new PRs in Subspace. So I think
I thought you have a fork that everything is merged in, so you can work from it.
But that fork is not like strictly like identical to the PR I submit to Substrate.
Can we update it
So
and just switch to it for now?
I don't think it's necessary. It's kind of like
well, like, if you cannot do anything anymore, then it's kind of necessary. If you can still work on something.
You know, I can work on parallel, like on my own fork and the Substrate PRs, but I just want to see that there might be some time I'm unable to like submit the new PRs to the Subspace.
Okay, but you think it's likely that they will accept the revision that you have, right?
Yeah, I think the review are like pretty slow.
In the meantime, can you work on these additional test cases?
Yes, definitely. I'm working on that.
Yeah. Okay. One question I had about so the way you have the secondary runtime on the primary chain right now, you have this like independent WASM blob that you kind of instantiate when you need to run a fraud proof verification. Is that right? Like a second VM outside of the main runtime, or I guess inside the main runtime rather?
Not yet. Not yet.
Okay. I mean, what are you thinking? How is that going to work?
Actually, I initially imagined that it's kind of like this secondary runtime will be like will be a storage item like of the primary state, right? So whenever you want to retrieve this secondary runtime, you just like retrieve it from this state. So
okay,
I don't think there is a problem with that.
And then you instantiate that as like a sub runtime within the primary runtime, like a box in a box.
No, like secondary runtime will be like secondary runtime. It will just read the blob from the other place. Like every time the primary runtime says that there should be a runtime upgrade, the second runtime will do the upgrade.
But how do we like instantiate or run the secondary runtime? Like what's the execution environment or the context?
Actually, like forget about this like primary runtime and the secondary runtime. It's just like to instance wasn't like a virtual machine, right, and to run a method with the core data. So from the perspective of this VM, like there's no difference with primary runtime and the secondary runtime. As long as you have this code for the WASM, yeah, it's everything there.
So are there two WASM VMs or one WASM VM inside another WASM VM? Or are they just both the exact same?
They are exactly the same.
Okay, maybe I misunderstood how you were describing the way that you bundle up the blob. So you can have two WASM blobs running inside the same WASM VM at the same time.
So when you do you mean like the time when we verify this for the proof?
Yes. Yes.
Okay, when we verify this proof, right? We fetch this secondary runtime from somewhere, right? And then once we get this runtime, and we have the method, we have the code data, we have the fraud proof, we can reconstruct a partial try to execute this exchanging, right? It's just like to execute an exchanging on the primary chain as a normal exchanging. So it's nothing special there regarding this exacting this proof for this exchanging. So that's nothing special between you running an exchanging or you running this fraud proof and you apply a normal exchanging on the primary chain. There's no difference.
Okay, I still don't understand, but it's probably just because I don't have a good understanding of the implementation of the WASM VM. But I guess if it makes sense to you, Nazar, we're probably okay.
I think it makes sense to me, but we'll also have some discussions later. So
yeah,
okay,
definitely.
Okay, awesome. Sounds like great progress, Liqiang. So once we merge this PR from Substrate and we get the secondary runtime working in the primary node in the farmer, that's kind of like a big milestone, right? Then we can maybe run an executor on the testnet at that point and merge everything in.
Yeah, I think so.
Okay. Assuming that.
But I think it still need a few more weeks at least.
Yeah, that was my next question. Assuming this PR is merged, yeah. So you're saying 2 weeks is your estimate right now?
At least.
Okay. Okay.
all right, that seems to be all. Let me share my screen now. This is not it. It's a window without a name, but I think this is the right one. Yep. Okay, so the week before, I had this small innocent pull request, which wasn't really worth talking about, but the reason it was there is the foundation for some of the newer changes. So the thing here is that some of the things were just moved. We basically had some of the CLI specific things, like commands in the library that we didn't need. So I just moved them to the node specifically, and then we can extend it. And in most other cases, we just use in service, so we don't really need most of these things. This is only for the secondary chain inclusion. And that was necessary in order to introduce the new feature, the command for importing blocks from the DSN. So this is basically the way to start archival node from the distributed storage network instead of syncing from the other nodes, like in regular Substrate sense. So the way it works is that in the node implementation, there is a new command, which is import blocks from DSN. It expects to receive the bootstrap node, how to join the network. And from there, it will discover other nodes. It will try to sync. It will just, we should probably show it like this. It will be more readable. So the process is the following. We basically go from the segment index 0, so like from the beginning of time forward, and we try to request the source pieces for every segment that we have from the history. We go just to the network and try to request from the distributed storage network. Once we have these pieces, we can try to reconstruct the whole segment as such using reconstructor. And then we basically read all the blocks and we import them one by one. And then we start over again. So this is like a simple way to have the full archival node syncing from the DSN. So at this point, we may not have archival nodes in the network at all. We just have the archived history. That's fine. So this is like a separate command. You can start it, and then you can restart the regular mode, and it will like sync to the tip of the chain from the last archived blocks, which is like maybe 100 blocks away from the tip. And this is like a simple initial implementation, which is not handling the cases where, let's say, some of these pieces are not available, so we need to retrieve the parity pieces. It doesn't handle the case where some of the source pieces don't match each other, where you like downloaded it from different forks. So you need to like distinguish what is the longest chain and how to resolve that. So none of that is handled yet. But it will be in the future. So this is like the foundational implementation that I was talking about for a few weeks. It's finally merged into the main branch. The only change I'm waiting for is to have instance fix for the block production, because I was building on top of the older revision to make it work. Beyond that, on the core protocol, I don't think we had many changes. There was like a lot of work on CI and that kind of thing, but it's not really about the core implementation. The other thing, which is probably slightly related, but not really about the protocol itself, we have the OpenCL branch now in this sloth library repository. There is one big commit that was squashed with the OpenCL implementation. We have that in here, and I will be working on that to make it clean and usable. There is a challenge right now that there are many specified things, of course, from C++ side, and then we have a lot of these functions which are just wrapping some unsafe calls without actually like protecting any invariants. So this is not actually safe, just a bunch of pointers everywhere. So I'll be working on like making structs and protecting invariants and exposing that in a safe way. But other than that, this seems to be working on Intel, AMD, and NVIDIA GPUs on Linux. It was verified with NVIDIA GPU on Windows. I believe it will work with Intel and AMD as well. And also will do some more testing on macOS on Intel GPU. Hopefully OpenCL works on Mac, so we will have that as well. And that will cover majority of cases that we have for the farmer. And after that, we can merge it into main and then switch our farmer implementation to this. And then hopefully take advantage of all kinds of GPUs people might have. So that was, again, something I spent quite a bit of time on. Yeah, I think this is about it of something notable from last week. Do you have any questions, concerns? All right. Well, I don't think you wrote anything yet, but maybe you have some questions or something you'd like to discuss. We have still some time.
One question that stands out right now would be I was looking at the README and I've noticed, and even right now you mentioned the archival node that is on the executor side, is it, or is it on, or is it something different from the farmer node that is actually storing the full blockchain storage? How, like, I'm just thinking, how is it different from the farmer node and the archival node that you just mentioned there?
Okay, there are several things combined here. I would say that we have step-by-step progress in terms of implementation from like the simplest, earliest version towards the eventual goal. And right now on the testnet or farmnet, we only have the like farmer node, and that is archival node, so it like stores everything. What we are doing right now is we are building the DSN so that the data is retrievable. This is why we can sync from DSN already. This is like the first step towards eliminating archival nodes. And then there is a part where the pieces that are archived, they are currently coming from this like farmer node to the farmer. Well, actually, farmer is also archiving it, but that's like an implementation challenge. So the eventual goal will be for the executors to archive things and broadcast it to the network, and farmers can just capture whatever they are interested in, like the sector of the network, and plot that. So farmer node will be basically a light client. The executor will be a full client, not the archival. And the archival history will be just on DSN. There will be no archival node as such on Subspace. But that is not the case yet. That's why we are talking about these like different stages of implementation.
All right, cool. That makes sense. The second question was the slot implementation that we are seeing for different GPUs as well. Like that is initially when we are starting, when we are plotting out at the initial time, right? Like when solving the audit, it's usually the binary search tree that we'll be looking at to get the tag. The GPU is only used at the initial plotting of the storage that is given to the network, or is it?
So GPU plotting, it's like just encoding that is happening on GPU. And we already had CUDA implementation. So we had CPU have it optimized in assembly. We had CUDA implementation in PTX, which is basically also assembly for GPUs. We are just now having another implementation which supports even more GPUs. So it's more universal. And that is primarily useful for the initial plotting. You will still do like replotting as the process is like going, but you'll only replot half of your plot when the history doubles. So when it's like exabytes, it will be very rare. So you'll do that on CPU. Decoding is only CPU. We don't have decoding in GPU implemented at all. It's just useless. It's very fast already. And commitments databases are also done on CPU. That is not something that is, from our opinion, makes sense to do on GPUs. So yeah, that's basically for someone who is joining the network and they have like 5 terabytes and they have like fast disks. They just want to plot it as soon as possible. And use as little energy as possible as well, because GPUs are more efficient in terms of energy for parallel encoding.
Okay, good, makes sense.
Yeah, if we have some time, I just want to say that, the thing which hit me right now was that Rust actually has the OpenCL implementation, which is quite convenient to use. I've used it a bit for university purposes. Yeah, I need to write some OpenCL code, and it works quite good. I just look at the source code of the Sloth. It seems that just using the VC bindings, right?
Okay, the way it works, there is a C++ library, which is then included with CFFI into Rust, and that's called from Rust. So eventually it's just one binary, but there are like different languages for different parts. We do have one repository where we're experimenting with AES, and we had the ASNI implementation with intrinsics. We had even VAES from Ice Lake and newer CPUs on the Intel side, and we also had OpenCL. So I used OpenCL bindings in Rust. That wasn't super convenient, and the guys that were working on this implementation in C++ and in like assembly very low level, they're not super skilled in Rust, so that's why they wrote it. Potentially at some point we can rewrite it, but it's not the priority by any means.
Yeah,
so,
yeah, I get it. It's just that I look at the code itself. It seems that the bindings to OpenCL itself, were not C++ ones, but they're C ones. It's just that there are a mix of both, like C and C++. Yeah, and the thing is that like some of the nice features from the Rust is like like that library which is called OCL. It has like iterators from the platforms and everything. It has nice safety and everything. So yeah.
Well, I remember it was really painful and buggy to use. Like OpenCL in general is not very friendly, less friendly than CUDA, but we will probably switch at some point. Yeah.
Yeah, true. Yeah, I mean, it's just that I had some experience with it and it felt okay. Yeah, of course, CUDA support will become way better. Like I guess soon, like within a year or two, in Rust. But OCL feels very rustish, apart from the writing C code, I guess.
Okay.
Yeah, I mean, we were using OCL like 2 years ago, but I'm sure the API has improved and the usability has improved quite substantially since then. We did OCL with the AES library, right? Sorry.
I believe so, but it was kind of abandoned back in the day, unless someone really stepped up and started working on it again. I believe it was like really not in a great shape there. But maybe something changed. Yeah, it was like 2 years or 3 years.
I mean,
like in the previous life.
Yeah, like it's very weird what you're saying. Like I probably used some other library.
Maybe there is something new. Like everything is changing in Rust for better all the time. Okay. Any other questions, topics you want to cover before we wrap up? All right. Thanks everyone for watching on YouTube. We'll see you in 1 more week.